Hello, and welcome to the future of farming. Fossil fuel-free or F3 farming is a new farming system that eliminates most fossil fuel-based inputs. Global agriculture accounts for 12% of greenhouse gas emissions. In the U.S., that figure is over 30%. Farming without fossil fuel is not only plausible, it's practical, as you will soon see. It's also inevitable. Between a fixed supply and pressure to switch because of climate change, its days are numbered. It can also be profitable since half of consumers are concerned about climate change compared to organic's 4% market share. Given a choice, many consumers would choose food produced without fossil fuel. In terms of carbon management, there are three main problems. It takes about 1 barrel of oil equivalent per acre per year to grow crops. Current farming practices lose 4 to 5 tons of topsoil per acre per year. And off-farm income accounts for over 90% of farm operator household income. Farms produce 300 kilograms of carbon emissions per acre per year and lose 100 kilograms of carbon per acre per year via soil erosion. Farmers have little to no financial incentive to manage carbon. There are no strong market signals yet. The 5 main fossil fuel inputs are fuel, fertilizer, pesticide, seed, and electricity. Diesel is the most obvious fossil fuel input. It's used in tractors, combines, trucks, and other equipment. The alternative is biodiesel. It can be grown and processed on farm. Full cycle farming solves the food fuel competition problem, where oil is processed to food grade on farm, rented to restaurants, and taken back to be processed into biodiesel. Biodiesel production has 2 main byproducts. Oil cake is a high protein animal feed and direct replacement for soy meal. Glycerin can be made into soap and sold for additional income. Natural gas is the primary feedstock for synthetic fertilizer. The Haber-Bosch process burns natural gas to draw nitrogen out of the air. High nitrogen inputs are usually required by hybrid varieties bred for high nitrogen input. Many heirloom varieties produce good yields with far less nitrogen. Alternatively, nitrogen can be produced by livestock, legumes, and soil life. Most pesticides are fossil fuel-based. Plants with a high Brix value are naturally pest-resistant. Brix is a measure of the solids in a plant's juices. Higher solids means higher sugars and proteins. It also means a healthier plant, which is better able to resist pests. Harrowing, cultivating, chaff collection, and double cropping are all techniques which can reduce weed pressure. Most farmers switching to organic notice an initial increase in weed pressure that tails off over time. Hybrid and GMO seed is fossil fuel intensive. It can take 2 to 3 years of crossbreeding multiple times just to get 1 year's worth of seed, with each generation using fuel, fertilizer, and pesticide. Saving seed allows for local adaptation, protects the food supply with genetic diversity, and is lower in cost. Housing animals 6 months a year produces a lot of manure and carbon-rich bedding. This can be anaerobically digested into methane and digestate, which can be further composted for fertilizer. The methane can be used to make heat or electricity. Solar panels and micro wind turbines can be used to charge batteries, providing a very reliable F3 power source. U.S. farmers lose 4 to 5 tons of topsoil per acre per year. This is a layer only 1/32 inch thick across an entire acre. Synthetic nitrogen harms organic matter and contributes to climate change with both carbon and nitrous oxide emissions. Pesticides also harm soil life, and soil life is essential for building organic matter and sequestering carbon. In order to survive, farmers need to make a profit. The market is not yet signaling that carbon management is important. Low food prices have traditionally been the main market signal, and government subsidy programs drive down food prices by encouraging overproduction. Growth in the organic movement proves that consumers are beginning to care about more than price. Farmers need market signals telling them to build soil organic matter and sequester carbon. The government could help by implementing carbon credits, but don't hold your breath. The climate change problem is dire, and governments tend to only respond after it's too late. To date, there has been no leadership from either the agriculture sector nor government in terms of solving the climate change problem in the context of agriculture. Consumer demand will start to make a difference. To create consumer demand, there has to be F3 food choices in the market. There is nothing else out there that's going to bring these choices to market. The organic movement was driven by Rachel Carson and J.I. Rodell. It spoke to people's desire for more natural food, but it was focused on chemicals and not climate change because climate change wasn't on the radar back then. Organic was never meant to be a solution to climate change. It's fuel intensive with many trips to the fields. It uses hybrid seed. Carbon sequestration is not its primary goal, nor is being F3 part of the organic certification process, and most organic farms would fail to be F3 certified because they use conventional diesel and electricity, amongst other things. As we've seen with organics, consumer sentiment is slowly changing. More consumers are concerned with climate change, about 50% compared to 4% market share for organics. Thus, the market potential for F3 food is greater than for organics. An F3 farm can be certified organic, but it adds requirements not in the organic standard, and since the USDA owns the organic standard, it's unlikely to go F3 anytime soon. The fossil fuel-free farming system proposed here can be more profitable than conventional farming practices. Profit is gross sales minus costs. Under the current system, farmers have no control over their costs or their prices. Most farmers are price takers. The only thing farmers can control is their gross. The only way for a farmer to increase their income is to increase their gross. This system takes a different approach. Instead of focusing on gross, this system focuses on lowering costs and raising prices, helping farmers become price makers. Most farmers really care about profits, as they should, and this system lets the farmer focus on profit and not on gross. How is this possible? By switching to an organic-style no-till system, switch to hybrid practices, put animals back on the farm, change the crop rotation, and sell direct to consumers and add value whenever possible. The old corn-soy supported CAFO system's days are numbered. The crop rotation of the future is double cropping winter canola and barley, and double cropping winter canola and grain sorghum and pasture. Double cropping is growing 2 crops in 1 year. This is accomplished by planting 1 crop in the fall and leaving it in the field over the winter, then harvesting in the late spring and planting a second crop, which is harvested in the early fall. Why winter canola? Winter canola allows for a second crop in a year. It provides ground cover over the winter to stop wind-driven erosion. It's the best feedstock for on-farm biodiesel, and canola oil cake is a high-protein animal feed. Grain sorghum is corn's biggest competitor. It's a direct replacement for corn and animal feed. We grew 433 million bushels in 2014. It also has better drought tolerance than corn, and as the climate warms, this will be a critical advantage. There is currently no GMO grain sorghum on the market, and if they do come to market, sorghum is much less prone to cross-pollination contamination compared to corn. Why barley? Barley can be sprouted into green feed mat like wheatgrass trays for fresh green feed in the winter. It can also be grown as a forage or hay crop. It can also be fed as a grain. CAFOs are not sustainable. Farmers don't like operating them, their neighbors don't like living next to them, consumers don't like eating meat from them. Animals on pasture live more humane lives, taste better, and are more nutritious. Management-intensive rotational grazing is a system of temporary fences which allows animals to be moved daily to fresh pasture. It allows for double the normal stocking rate without damaging the pasture. High-brix feed can cut feed rates in half. Together, this allows for a 4x increase in output per acre over conventional systems. Cost reductions. Fuel, fertilizer, pesticide, and seed can all be produced on the farm at the basic cost of capital. Only mineral fertilizers like high calcium lime and soft rock phosphate have to be brought in. They cost 1/4 of what conventional fertilizers cost and have a low carbon footprint since they either mined or byproducts of other processes. Higher prices. Certified organic meat has higher prices than conventional. F3 certified meat should slot in between conventional and organic. F3 plus organic should fetch the highest price. Selling direct to consumers has a higher gross margin, and adding value can further increase margins. We are seeking funding to set up 3 financial models using this system. The first model is research and development. A prototype farm has to be set up to demonstrate the feasibility of this system. The demonstration farm can also train new farmers. Experience is a requirement for USDA loans. Once the R&D phase is complete, the second franchising phase can begin, involving multiplying this system with startup turnkey farms. The last phase is conversion of existing farm operations to F3. Farmers are risk adverse. Skeptics will be many. Both need to see a working model. Open record keeping will prove the profitability of this system. The first goal is to raise $1 million to set up the demonstration farm. Cost analysis. Land and capital cost the same for all farmers. Our analysis is focused on changing input costs and increasing sales. This model should see a 50% reduction in fuel costs, a 100% reduction in seed costs, a 75% reduction in fertilizer costs, and a 100% reduction in pesticide cost. Price analysis. Organic prices are 68% higher than conventional on average, and selling direct to consumers adding value can increase margins by 200 to 250%. The project is organized into 3 categories. The F3 Farming Foundation is a 501c3 focused on research and development, education, and outreach. The F3 Farming Franchise is a for-profit corporation. This is for investors and startups looking for turnkey operations. And the F3 Farming Certification Program is focused on certifying existing farms as F3. For more information or to donate to our Kickstarter fund, please visit our website, f3farming.com. Thank you.